Hello, welcome to today's training. Today I'll be talking about data type, and it's absolutely important that you understand today's topic. This is building up on our last discussion where we talked about PLC tags. So, here at first, I'm trying to modify our project. Before now, we've been using the S7 1200. I've introduced the S7 1500, and the reason is because there are some data types that only S7 1500 can handle. S7 1200 cannot handle them. So one of the things that I will share with you is this information from the Siemens page. I'll put this link on the description of this video so that you can go through it. On this page, you can read about different data types. You can understand which PLCs support what kind of data types. I think you should go through that. You would actually need it. You also don't need to read it to memorize. Of course, during your projects, you will come to understand some differences and how to apply them. But today I'll be talking about most of them. So I just quickly wanted to show you that I'm adding an S7 1500. After this video, I will delete the S7 1200 because there are still a lot of modifications I need to do. But because I want to talk about data type, I've added the S7 1500. So everything I'll be doing now will be under the S7 1500. And as we discussed in the last video, if you've not seen it, please check it out. Whenever you add the PLC, you have a default tag table. It shows up there. I've added this PLC. The default tag table is already showing up there. So before going much further, I'll show you something which I just developed to give you an understanding. So what is actually a data type? In the last video, I explained what a PLC tag is, naming items or things inside of PLC. Now, whatever item exists in your PLC takes up some space. Like you have a memory card on your phone, you have a storage where you keep things. So usually you define your storage based on whatever you want to put in there. And that's exactly the same thing that we do in the PLC. So usually when you're programming or when you want to program, you need to define what are you actually trying to do. What's the size of the space that whatever you're working on would take. As an example, we have here a Boolean data type. Our past project, I've been doing some little examples, and I think for now we've been working only on Booleans up until now. I've also shown you analog signals, which we will still talk about. So here we have a Boolean data type. Usually you have, let me say, example here. With 6 example, I'll just leave this open. So usually you have a Boolean data type. And how do you use that? Usually a Boolean is a single switch. It's a state, usually a state. So it could be either true or false, could be either on or off, right? So it takes one bit inside the PLC. One bit is just one dot, one space inside the PLC. So that's a Boolean. So it can either be 0 or 1, it can either be true or false, can either be on or off, things like that. You use a Boolean for it. The next data type is a byte. So a byte comprises of 8 bits. 8 bits. Now, in the PLC doesn't count from 1, it starts from 0. So if we count 8 from 0, you have 0 to 7, and that's 8 bits. And 8 bits make up a byte. So when we say 8 bits, we call it a byte in data type. When you want to address such, you use B1, MB1. So M here just signifies a holder, like a memory in the PLC. So here it's memory byte 1, just 1 byte. On the bits you have dot. So you have memory, instead of memory bit 0, we use the dot, the point. to address a bit. So here you have M0.0. So the next address here would be M0.1. The next one will be M0.2 up until M0.7. So that's the 7th bit in this byte where this bool is existing. We also have what we call short signed integer. So whenever you see the signed value, this signed, whenever you see this word, it means that it is a value that can go down to the negative. That is the sign word. So an example of that is when you have a value from minus 127 to plus 127. For example, you can use this, let's say temperature, right? Temperature in Celsius. So temperature in Celsius, you should have something from, let's say, minus 20, minus 30, minus 40. You can go up to plus 10, plus 30, plus 50. So if you want to talk about temperature of a particular city, then this is the best to use, right? Because maximum, let's say minus 40, minus 50, and then you cannot go above plus 50, plus 40. You cannot have more than 127 degrees centigrade in any place on Earth. I don't imagine that, right? So if you're talking about a geographical temperature or place, then you can use something like this. You also have the unsigned. So the unsigned is a value that cannot go below 0, right? So here you can talk about um, speed, maybe speed of a car. You understand? Speed of yeah, let's say speed of a car. You can say speed of a person as well. So you cannot go minus, right? You can only go from 0 upwards. And these ones take up a byte, which are 8 bits, right? This three that I've discussed now. We have characters. Characters are examples when you want to use alphabets inside your program. A character takes up also 8 bits. 8 bits. So it's also under the 8 byte category. And then you have the word. The word is a 16-bit string. So usually, maybe when you want to depict something in hexadecimals, and you need to write something like this, WI 16 hash ABCD, then you're using up 16 bits, which is 2 bytes. An example of addressing such would be MW6. So now I'll come into these examples briefly. Another one is the integer. So standard integers signed again, you see, which goes from minus to plus, right? So here you can have minus 327. So if you have a data type that can go up until this value, then yes, it's better to use integer. Directly you pick up a data type with integer, it's signed. When you use the U in front of it, then it becomes unsigned, which means it can only go from 0 up until the last value. Now, one thing I want you to already notice is when you have the signed values, you go from minus and the maximum is 32767. But when you go to unsigned, it doubles up the space. It doubles up your size in positive. It doubles it up. Here you're breaking into two sides, minus and positive. So you can go minus 32,000 or up to upwards positive 32,000. But when you go unsigned, it adds this minus on top of the positive for you. So you can go from 0 up until 65535. So actually uint and int are some of the most used data types apart from booleans in programming. Very, very important. You also have the date data type, which you can use for calendars. If you want to write a date like this in the PLC, D asterisk, then you go up for the 2026, 2601, which is a date. An example looks like this in the PLC. You have a double word. So when you go into the double words, you're already going to 4 bytes. So this one's take up double words in the PLC. You have examples like this. Maybe you want to show states inside the PLC. You have the double integer. We left integer here. You have the double integer. For example, you want to go for very big values of data, very big value. You want to store a lot of values, maybe amount of products produced in a day. So you can have up to around, this is around 4 billion. So you can use unsigned integer for this. You have the real. Real is used when you actually want to express things in decimals. So I used an example of temperature earlier where I was talking about minus to positive. Usually temperatures usually come with some percentage. So today is maybe 7.6 degree, where you actually need very fine data. You want to go into the decimals, then real is the best. So real is also one of the most used data types on the PLC. So in real, you can go from minus to positive. It's a 32 bits, so it takes quite a lot of space on the PLC. You have time as well. We talked about dates. You have time because time can also work in up down till milliseconds, to hours, to minutes. Then you also have them taking up 4 bytes. You have the long reel, and the long reel is actually the longest version. As you can see here, it states S7 1500 only, and this is one of the reasons that I changed the PLC in the project, so that in case we want to have an example of this L reel, it only functions on S7 1500. So you see, as a programmer, you need to have an holistic view. If you already know that you need the project you're working on needs a value that you would use the L reel for, that already tells you that you cannot use S7 1500 for it. It already tells you that. So you need to change your PLC to S7 1500. You cannot use S7 1200. You need to change to S7 1500. Now, for example, look at the logical addresses. For a Boolean, you have 0.0. Like I mentioned, it could also be 0.1, can be 0.2, up until 0.7, can be 1 point, can also be 12.7. It can be anything, just depends on what the main address is. But up until 7, it cannot go up until 8 for a Boolean, for a bit, direct like this. Of course, you can pick, if you're in a byte, a word, you can also pick up onto 8 or 9 if you want to address a specific bit inside. But I don't want to confuse you yet for now, so just know this. All right, if you want to address a bool, it has to be somewhat like this. Now, in a byte, MB1, MB2, MB3, MB whatever, that's a byte. For example, here we have MB1 for this address. So let's say we start from 0. Let me say 5 now. So we've used the address M0. We've used the 0 address, but we've picked only 1 byte in it. Now we want to address another byte. We cannot use the 0 anymore because there's already a bit that we are using there. We need to go up to the next address, which is why this is M byte 1. Now, because if we've used byte 1, we need to go to the next address, M byte 2. It's just 8 bits. We've used 8 bits again. We need to go to the next byte, MB3. Next one, MB4. Now, we want to go to the next address, which is a word. A word is what? Double bytes, right? And we don't want to go into this guy because this guy starts from 4 and ends somewhere in 5. So 5 is currently free now, MB5. We can as well start this guy from MB5, but we want to start from MB6 to avoid data collision, to avoid us going into this data. So we start from word 6, memory word 6. So memory word 6 takes address, because it is double byte, it uses 6 and 7. It uses 6 and 7. As I mentioned, this uses 4, so 5 is free, so we can as well use memory word 5 and 6. but just for example's sake, we're using 6 and 7. Now when we use 6 and 7, what is available from 8? So the next one takes 8 and 9, which is 8 and 9. The next one takes 10, 11, because it's 2 bytes. The next one takes 12 to 13. Now we are going into 4 bytes, which is 2 words. We stop at 13, we start at 14. And when you go into 14, because we're using 4 bytes, this is 1 byte, 2 byte, 3 and 4. So 1 byte, 2 bytes, 3 bytes, 4 bytes. So it means memory bytes 14, 15, 16 and 17 are used. The next one, which is another 4 byte data type, goes up to, starts from 18, 19, 20, 21, which is this 4. The next one starts from 22, ends at 25. The next one starts at 26, ends at 29, 30 to 30, 33. Now we have the long reel, which I said takes quite a lot of space, which is in this case 16 bytes, which is 4 words. 16 bytes, no, 4 words. 1, 2, no, this is 8 bytes, sorry, not 16 bytes. 8 bytes, because we have 1 byte, 2 bytes, 4 bytes, and then we have 8 bytes, correct? 4 words. So 4 words means this 2 bytes is 1 word, another 2 bytes is 1 word, another 2 bytes is 1 word, another 2 bytes is 1 word. So we have 4 bytes, which makes it's 4 words, 8 bytes. This one is 2 words, 4 bytes, and the one in purple is 1 word, which is 2 bytes. The green one is just 1 byte, the yellow is 1 bit. So with this, you can understand how these data types take up spaces on the PLC. Examples, I've also shown them here. For example, for the string, you want to write something like a text. Now for the string, I did not show the data structure because the string is what you define. So when you're setting up a data type of string, the PLC would actually ask you what should be the length. So you have to define the length of how many characters the user can write in there. However, you have a maximum of 255 characters according to IEC 61131.3 standard. And it takes 1 byte per character. So you can use up until 256 bytes, and it takes plus 2 bytes for the header. That's why you have 256. So 254 plus 2, 256 bytes. If you go up until 254. So in some cases in your PLC you want to write text. So for example, you want to create a text that shows up somewhere in your program or on the HMI, and then you say when this is this, then string, say open or say closed, things like that. You want to show that in your PLC, then you have to use string. And because string, you have to define what number of characters, then you have to define that when you're declaring it. There is also a long data type, DTL, long date structure, which is DTL, date and time long. Date and time long. This one is based on structure. So a structure is also a data type, which means you have to combine any of these data types to form your own structure. So when you want to create a structure, you have to form using any of these data types. So you can mix, you can say Boolean, word, integer, double integer, blah, blah, blah. Underneath this date and time long. So I hope I've been able to explain some things to you about this. Now, if we go into, for example, if I create a new tag table and I just quickly want to import, no, I cannot import. So I'll just quickly create some random data types just for you to see. Let me say test, and the data type for test here is Boolean, fine. So it takes, so I'll just use M here, M 0.0. Another, I'll drag this down. Just give me a lot of text. test 1, test 2. Okay, so just examples. Here now, I want to use MB1. So there's an error here, right? The address entered does not match the data type. Yes, because I used Boolean. Good example. So if I go to bytes, it works. There's megabyte, memory byte. Here as well, it's a byte, right? And I have to use, let me see if I use MB1, if you get an error. Good. So you see it's in yellow because I'm using the same address for two different tags, which is telling me that I'll be writing into the same location. I'll be putting two things in the same location. The address is already used by another user, another tag. So I just change this to memory byte 2. Good. Now I don't want to use byte anymore. We also talked about yeah. So I want to go to two words, 4 bytes, and we said that's either a word, integer. Okay. So I'll just pick, let me pick a word. So if I pick MB2, right? So MB2 also tells me no, the address is entered does not match the data type. Yeah, because I'm choosing a word. So this should be WMW, right? But don't forget that I'm already starting where this ends. So there might be some conflict here. So I can go up just to avoid being where this guy is writing, where this data type is writing. So we've used the word, which is this. Now let's go to two words. And an example of two words is double integer. So in my data type, I can pick double integer. You can also type it if you know it didn't, it will come out. So this is it. Yes. Oh, I was writing where we wrote there before. Didn't. So here, what are our example type? So we have didn't. I cannot use MW anymore. I have to use MT, and you can see it's already giving me errors. So if I write MW, so this is a word. So it takes MW 3 and 4. So let's say we start from 5. It will not work. I have to use MD because double word. Good. See, it works. Now I know this guy is using double words, which means it's taking 5, byte 5, byte 6, byte 7, and byte 8. If I want to write anything now, it should be MD9. If I don't want my data to go into this guy, because I haven't changed this. If I put MD8 here and I change this to maybe double word, so let me say D word, it will work. However, this MD5 is writing in 5, 6, 7, and 8. And I'm still starting from 8 here, which means this test 4 will write on 8. The last byte of it will be on 8. There will be an overlap. So it will write here, up until this 4. However, I will now start the next one on top of this again, which is wrong. So that's what you always want to avoid. You need to ensure you know that in your programming. Okay, so to conclude on this, I want to show you what I've done to show you the L reel and the structure data type. So I've created a DB, a test DB. I can also just show you directly, so I can say test db2, and it's a global DB, which means I can use it anywhere on the PLC. And here I want to create a data, which is test1, and I want to use this as LReal. So here I'm able to create an LReal data type. I can also create a structure. Let me say I want to create a structure for a pump. I can explain this later, but I've told you that when you want to use the structure, then underneath that you see it steps in. So here I can say the structure name is a string The structure, the pump name is a string. The location would be maybe a number, so I can say uint, unsigned integer, it will not be negative. And then I can also say the speed is uint, whatever, or I can use int. So basically, when I click on this, the structure that I've built underneath the pump is taken away. When I click on this, it shows everything I've built under this pump. So you can create data types underneath a structure, but you have to mix it with the standard data types, any of these ones here. So basically, this explains the data type in the PLC. There is also a data type which you can create, which we call the user data type, UDTs, meaning you specifically trying to create specific UDTs by your new self. So for example, if I say add new data type here, and I want to create a new data type for a pump like I was showing earlier, so I can say location. So if I want location to be a number, then I can say uint. First, I wanted to name of the pump, I want it to be a string, right? So when I define it to be a string, yeah, default value, it's here. So I can also say what's the speed of the pump to be uint, right? I can also say what's the status of the pump, is it on or off? So this would be a boolean. If I go into our data and see if there's probably any other thing we might need. Yeah, let us say error in case we want to define an error. So we say word error status. We can use word for that. Yes. So we save this and we close it. Now we can rename our data type. Rename to be pump. So we've created a UDT of pump, which means instead of creating a structure directly here, I can come here and say room pump, and my data type for the room pump, I can just directly pick what we've created, which is pump, which is our data type. And when we do that, everything that we created here shows directly under the pump. So you can reuse this for standard, you can make it the standard structure in case you have more than one pumps in your projects. So probably you're working on a project that you'll be repeating a lot of devices. You just create your own data type. If I come here and I add another data, so let me show you side by side, and I had another data. So for example, I had, let me go in and add row, and I say I want to add whatever. Let me just add something like size, right? And size is maybe an integer. So I've added one more data to this, to my UDT. I'll save and I'll close it. Wherever you've used it, it shows an error, right? So what do you need to do? You right click on this and then you update it. So when you click on update, it will show. Now the size is showing, which makes it very, very easy for you when you're working on projects that requires quite a lot of the same thing in huge amounts. So I'll drop all the resources on the GitHub page. I'll also add the link to this video. If you have some questions, you can ask. Thank you guys.